last part of chapter 8 is about periodicity. Let's find out about the periodic law and then the properties that change. Periodic law says that when elements are arranged based on their atomic number in the periodic table, their physical and chemical properties vary periodically. So we are going to study 3 of these periodic properties. The first one is atomic radius, the second one is first ionization energy, and the third one is electron affinity. So let's start with atomic radius. What do we call atomic radius? We basically talk about the covalent radius or covalent radii. You know that in covalent bond, when the atoms overlap and hold this is the area that atoms hold the valence electrons inside them, like outermost level electrons inside them. So the distance between the 2 nuclei of the atoms is called radius. So we're talking about this distance. Atoms form a covalent bond. When they form a covalent bond, we call it an overlap. They overlap with each other to hold the shared electrons better between them. So the distance between the nuclei of the 2 atoms that participate in that covalent bond is called atomic radii or covalent radii. This radius, the atomic radius changes, the decrease from left to right across the period and from bottom to top in a group. Why there is a decrease from left to right? Because from left to right in the periodic table, atomic number increases, right? In each period. Along with increasing atomic number of protons increase and then electrons at the same time, right? So positive and negative charges are increasing at the same time. Protons inside the nucleus with a positive charge attract or pull the electrons. That's why atomic radius decreases, because from left to right across the period, atomic number increases. Atomic number means number of protons. But at the same time, number of electrons are increasing also. So protons inside the nucleus will attract or pull the electrons more towards themselves. They cause the atomic radius to be less. From top to bottom, you have an increase in atomic radius, and it makes more sense because you have more levels of energy. It's just like always say, just like an onion with different layers. The more layers your onion has, you have a larger onion, right? So if the number of layers increase, the atomic radius increase from top to bottom. So from bottom to top, you have a decrease because the number of layers are decreasing. You're peeling off your onion. So keep in mind, because I'm going to talk about the other trend, for atomic radius, you have decrease from left to right, from bottom to top of periodic table. That's about atomic radius. The second trend that varies periodically from left to right in each period is first ionization energy. We're talking about ionization energy. So what is it? Is the minimum energy you need to spend to remove an electron from a neutral atom and change it to a positive ion or cation. Because whenever an atom loses an electron, changes to a cation, right? The trend of first ionization energy change is just the opposite of atomic radius. So just memorize one of them, you will learn the rest, the other one. Why? Because increase from left to right and from bottom to top, because by decreasing the atomic radius, you're closer to nucleus, right? That nucleus doesn't let you to pull the electron that easily. So by decreasing the radius, you have an increase in spending energy. You need to spend more energy to remove that electron. And the same here, when you go from bottom to top in a group, you have less levels of energy. You're closer to the nucleus. So it's harder to remove the electron when you're closer to nucleus because nucleus has a positive charge and pulls the electron. So it doesn't let you to remove the electron that easily. So the trend for atomic radius change and for first ionization energy change is just the opposite of each other. Okay? The last trend that we, or periodic property that we study is called electron affinity. Electron affinity is somehow the opposite of first ionization energy. For ionization energy, you spend energy to remove the electron. For electron affinity, you spend energy to add an electron and form an anion. So electron affinity that we show with EA is energy change for adding an electron to a neutral atom to make an anion. The more the negative charge means you're making a more stable anion. The more the positive charge means you are making an unstable anion. Unfortunately, unlike first ionization energy and atomic radius, you don't have a regular trend across the period or among the groups. So it varies in the periodic table. Most of our emphasis is on the atomic radius and the first ionization energy. But this is one of the periodic properties, electron affinity, that changes. For some of the elements is more negative, means their anions is more stable, and you expect it for nonmetals, right? And when there is a positive change, means anion is unstable like metals. Metals don't like to be changed to anions, right? So their electron affinity will be more positive. The rest of this chapter 8 is about the properties of each of the elements. You can go over them, and these are just the general properties of each group. Please practice on so many electron configurations, noble gas configurations, orbital diagram, and also work on magnetic properties, paramagnetic and diamagnetic. I hope this video was useful. See you for the next video, chapter 7.